Okay, so welcome everyone. Good morning to me and good evening to the people who are joining from India. Uh, we'll now have a keynote lecture from Dr. Deepak Patil, who is popularly known as Boss. He is the current president of IIT Bombay Alumni Association, and he has served as member of board of trustees for Shivashanti Snehalaya Sneha Bhavi Sanstha, an old age home near Alibag. Okay. So apart from this, Dr. Patil, the boss, has been serving in various roles in various capacities. He has been producer of Siddhaditya Takis, board member of Ideapoke, managing director and CEO of EdSoft India, vice president of Global Delivery Integrated Business Operations and uh, Transformations, managing director of Asira Software and Private Limited. His boss has also served as MD of Verifone India. So welcome, boss. Keeping time in mind, we'll quickly let Dr. Deepak take over and provide his 10 minutes talk to all of
Yeah,
us.
thank you, Sharat. I'm quite pleased to be part of this get-together, though virtual, with the Mysuru team, alumni. Let me, briefly tell about what is IIT Bombay Alumni Association is about, because it's like our second family, basically. So currently we have 32 chapters worldwide. Okay, and I'm sure Mysuru will become the 33rd very soon, hopefully. There are 13 chapters within India, 12 chapters in the US, and 7 chapters in the rest of the world. So that is the the spread of alumni association the last 20 years. Just it so happened last Saturday we had a celebration for AA completing 20 years. I don't know how many of you attended that, but it was a fantastic program. There is a complete recording available on the YouTube. You can watch it. So trying to say that we have completed 20 years. Within 20 years, there are so many things that AA has been able to do, and we're still aspiring to do more from help of all the alumni across the world. Some of the highlights of this are the activities that AA has taken due to the initiative of the alumni, the generous donations from the alumni, is basically anything related to the institute or the stakeholders of the institute. That is institute itself, its infrastructure, hostels, staff, faculty, students, and of course the alumni themselves. So let me go one by one. There are many things, but I will just highlight a few of them. There is something called a financial assistance program, which helps the students who are not in a position to fund, or like they don't have the financial capacity to bear the expenses while studying in IIT. And we have one unwritten determination, a rule, that no student of IIT Bombay would stop his or her education for lack of funds. So we help the students with grants, which includes either the fees or the mess bills or something like laptop, textbooks, or or maybe a combination of all of them. And then and we don't expect money to be paid back by the student, because it's not an agreement that this is a loan. It's not loan, it's a grant. But it so happens that the alumni, they remember this, and of course in the future there will be students like this. So once they start earning, they slowly they keep donating back, and that's how this fund has been going on for last so many years, and has benefited many people. Like many students so far. Then there is for the student, there is something called HATS, which is related to the hostels, like hostel alumni team stewardship. Hostel infrastructure, for example, you need gymnasium. Of course, IIT had a proper gymnasium, but just to make things easier for the students, because health also is equally important. We have, wherever there's a request, we alumni had donated funds to set up hostel or gymnasium. Within the hostel, badminton courts, basketball courts, music room, sitting room, lounge room, whatever, basically depending on the hostel requirements. Of course, and maybe the current students may not know about it, but we had, like, I come from the 77 batch. At that time, the mess workers used to be there who were not employees of IIT, but they were a contractual labor. And after they retire, they don't have any money to take care of themselves. So we decided to help them after retirement. So we created another fund through HATS to help the mess workers after their retirement. And we started donating rupees 1 lakh each for the mess workers who have completed 25 years. Then there is something for the faculty, just to attract young, brilliant faculty, because unless you have a good faculty, you cannot dispense good education to the students. So we have something called Young Faculty Award. So when the young faculty, the faculty joins, then for the next few years, every passing year, we give them some sort of bonus kind of stuff. So that is sort of an attraction for young faculties to join IIT Bombay. And this has also been very successful. And the faculty has officially recognized this also, that this assistance, financial assistance from the alumni has been very helpful to them. Now this is for the incoming faculty. Now there is also outgoing faculty. I think till about 2002 or 3, the faculty that was retiring from IIT didn't have any benefits as far as the health insurance is concerned. And generally you need health insurance only when you get a little older. So we started one legacy project, started with one Silver Jubilee batch to have a retired faculty wellness fund. So every year we pay the premium for the health insurance for the retired faculty plus the spouse. So that has been another thing that alumni have taken up, AA has taken up. Then there is something called benevolent fund, where the alumni or students, within the family or themselves, they suddenly feel some emergency medical assistance, like, sometimes you have certain kind of diseases or, difficulties that you have health-wise, which demands, 15-20 lakh rupees, which we may not have at that point of time. So for that, this benevolent fund comes into picture, and we try to help as much as possible. Of course, and the reunions and all, you must be aware of Silver Jubilee, then decennial reunion. Nowadays, the events have been so successful that even having completed 5 years, the alumni started having reunions. Okay, so 5, 10, 25, 35, 40, 50. So even Golden Jubilee reunions have started now in IIT. So these are the things, various things that happen apart from the regular ongoing chapter events. The one that we are having right now is also an event, and that kind of thing keep happening across the chapters, which helps really the alumni to be in touch with each other, exchange ideas, networking, etc., which is very beneficial, because I believe that we have like about 55,000 alumni across the world, of which 35,000 alumni are actually life members of Alumni Association. So which is quite a huge organization. This is I think it is the biggest in Asia. So this alumni, this particular organization, the alumni We have lots of experience, expertise, knowledge, all kinds of resources available, that needs good networking so that right people meet the right people and help the right people at the right time. So that is what alumni get together are all about. And that is what Alumni Association is all about. So with that, I think I will not hold Dr. Suresh for his, I'm also keenly looking forward to this biomimicry talk, because this very interesting subject. I didn't know anything about it, so I just did a little bit of Googling, and I got quite attracted towards this subject. So I'm looking forward to listen to Dr. Suresh. So
thank you, Patil. I hope I will be able to initiate your interest in this subject.
Absolutely, absolutely. I have no doubt. Okay, over to Shara.
Yeah, let me just introduce the guest, today's distinguished speaker. It has been a very gratifying experience to me. Why? Because I am student of Dr. Suresh in the civil engineering department NIE, where he has taught me for 4 years. I see other of my teachers here. Dr. YMN was here, so and Dr. YJ was also here, I guess. So I thank all of them from deep of my heart for being my teacher. I'm grateful to all of my teachers and everyone. So Dr. Suresh is the managing director of Skylark Engineering Consultants, Mysuru. In his role as a structural consultant, he has adopted innovative methods for designing buildings. He earlier served as a dean of academics and professor and head of the Department of Civil Engineering, NIE Mysuru. He has also served as he has been an academician for 35 years. Also, he has also been a researcher and a consultant. During his tenure in NIE, Dr. Suresh was instrumental in popularizing students' event, which was Akar. We enjoyed it. We cherish all the moments we had during the time. He invited a lot of eminent speakers and brought in several performers to do cultural performances in those events. He has built several buildings for institute as a consultant and developed a CAD lab as he was in charge of the CAD lab in NIE. As a researcher, Dr. Suresh has published several books and in journals and journal publications. He has been involved in several projects sponsored by UGC, KS, CST, CRC. He was awarded structural design of outstanding multi-storied concrete structure ACCE and Ultratech Award in the year 2016. He has been also the recipient of Teacher of the Decade in Akar 2016 from awarded by the Department of Civil Engineering IIT Bombay, NIE Mysuru. So as a teacher, I remember him like when we were student, he would walk in with the same word every day. Like he used to start the class by telling, analyze. So Dr. Suresh holds. He's also alumnus of NIE Mysuru, my alma mater, and IIT Bombay, my alma mater. He holds civil engineering from bachelor's degree from NIE, a master's from IIT Bombay, and PhD from IIT Bangalore. So I'll request Professor Suresh to take over and just guide us, enlighten us about this interesting topic.
Thank you, Bharat. I hope you can all see the slide.
Yeah.
Is it visible,
Yeah.
Sharath?
Yeah, it is good, sir. Yeah.
Yeah. It gives me great pleasure in addressing all our alumnus of IIT Bombay. I recall my days in 86 to 88 at IIT Bombay, where I had spent good time at Hostel 3 and Hostel 8, and also I had 1 year of caretaker to Professor Sarda's house when he left for Canada. So I lived with my family, and we had a very good time in Canada Association. And I give my pranam to my professor late Limaye. With this, I just start today's talk with the introduction to biomimicry. Application of biomimicry to the materials, energy and water, and how we used it in structural engineering. I would like to make a statement that I have not done any research in this field, but I have collected a lot of information from books, journals, website, and from YouTube. So I try to prepare the slides with the encouragement I got it from Babu Narayan of NIT Surathkal, who did a similar lecture. And from that, I started looking into Jani M. Benu's presentation on YouTube and on other platforms. So with that, I start my introduction to biomimicry. What is biomimicry is? Bio means it is life. Mimicry means we imitate. We imitate the life, whatever the creations we have in nature, we try to solve our problem by looking at how the nature has created the problem and how it has solved that problem. So, and biomimetics is the study of the formation of structure or function of biologically produced substances and materials. Most of the problems what we face has also been faced by the organisms, and it has evaluated or evolved many solutions to these problems. Already we have successful models produced by our researchers. One of them is the leaf of the lotus, which is a very good water filter and water repellent, which is used mostly as a repellent due to hydrophobic material which it has produced by the nature. To figure out how we, the engineers, have used it, we have developed a paint about which I will be discussing in the coming slides, about how the lotus has inspired us to create a waterproofing material, and many companies in US have adopted this. Then we have a texture painting, which you can see on the slide. The texture paint nowadays is very fascinating and also adopted by many builders to give a good look to the outside painting. So how this texture has come? The texture has been taken from the leaf. These textures are very much similar to the leaf, and people have developed a methodology to copy or to imitate the texture of the leaf. And coming to aeroplanes, all of us know that we have imitated the birds. Particularly, a bird called hawk has been used as its shape to create a stealth bomber, which has started from there, and many innovations has taken to change its shape. Then we have developed Velcro. Velcro is nowadays in almost all the bags and other places, particularly when you look into your laptop bags, we have Velcro. How it has been arrived? This was been instrumental from George de Mestral in 1940 while he was hunting in Jura Mountains in Switzerland. He found that to his dog and also to his pant, the burrs of the seeds were sticking. Then he started looking into microscopic structure of this burrs, and he found that there was a locking system in this burrs, and that's how the Velcro was invented. See a video on the biomimicry, how it was created. This was created by Janie M. Benius. She is an American natural science writer. You can have about 3 minutes video on how the biomimicry
life's been on Earth
created
for 3.8 billion years. And in
I
that
hope all
time,
of you
life
can
has learned
hear the video
what works
and also
and what's appropriate
audio.
here
Yeah,
and what
yeah.
lasts
Whatever.
here. And the idea is that perhaps we should be looking at these mentors, at these biological elders. They have figured out how to create a sustainable world. So rather than inventing it from scratch, why don't we take our cues from them? These are earth-savvy adaptations. They're the consummate life. These organisms are the consummate engineers. They're the consummate chemists and technologists. They've learned how to do it in context. So that's the core idea behind biomimicry, is that the best ideas might not be ours. They might already have been invented.
She is the founder
Biomimicry
of
is
BioMimicry
innovation
Institute.
inspired by nature. It's a new discipline in which the people that make our world, the chemists and architects and material scientists and product designers, they ask themselves, what in the natural world has already solved what it is I'm trying to solve? And then they try to emulate what they've learned. Our work as a species is to create designs and strategies that move us towards being better adapted to life on Earth over the long haul. And when you ask how to be better adapted to this planet, there are no better models than the species that have preceded us for billions of years. You know, there are 30 to 100 million species, maybe more. And in all that diversity, there is a hidden unity. There are a set of operating instructions, how to be an earthling. And their life's principles like life runs on sunlight, except for a few organisms in sulfur vents at the bottom of the ocean, life runs on current sunlight. We run on ancient photosynthesis, trapped in fossil fuels. Life does its chemistry in water as the universal solvent, and we tend to use very, very toxic solvents, like sulfuric acid. Life depends on local expertise. Organisms have to understand their places. They have to know the limits and the opportunities of their places. And life banks on diversity and rewards cooperation. Life wastes nothing, upcycles everything, and most of all, does not foul its nest, does not foul its home. We're a very young species, and probably our best stance as a young species is to be apprentices to these masters. We need to replace our old industrial chemistry book with nature's recipe book. Our synthetic chemistry is completely different than nature's chemistry. We use every element in the periodic table, even the toxic ones. And then we use brute force reactions to get elements to bond or break apart. life uses a small subset of the periodic table, the safe elements, and then very, very elegant recipes. Low temperature, low pressures, low toxicity. That's nature's chemistry. It's a very different paradigm. And we have to ask ourselves, not just how to replace individual molecules for different kinds of molecules, but rather whole families of reactions. It's a big job to do that, but it's an Apollo project worth pursuing.
So that's the Professor June has given. She says that we run on sunlight. We use only, or the nature uses only the energy what it needs. It will not have excess energy. It fits form to a function. We may have a shell structure on many animals which we have copied onto our structures. We have learned in nature how the recycling takes place, and we have cooperation in the nature, and the nature has given us how to cooperate with each other, and we have developed many scientific methods to imitate the nature. We have to have a demand of the local expertise, the local requirement for the nature. We need to have this. We have to depend on diversity. That's what she said at the end of the lecture, what she gave. And we have to curb the excess what within we have. The examples for biomimicry starts from hippopotamus sweat, which contains a substance which fight microbes, and it acts like a sunscreen, and it also reduces the effect of ultraviolet light. The scientist from Japan says that the sweat of the hippo is the best example. You can see here, there is a reddish color at the face of the hippo, which is nothing but a chemical which has been formed from the sweat, which will make it to fight with the microbes and also protect the effect of the sun. The chemists have taken this sweat and they have analyzed, and they are trying to use this for producing sunscreens, which we are shortly getting from these experiments or from these findings. We also have seen in our Japanese train, that is bullet train. Earlier, the bullet train had a vertical face, and when it was coming out of the tunnel, it used to make a lot of sound. And the researchers and one of the engineer in the railways of Japan found that this should be avoided. He started looking at the kingfisher which tries to go into the water without producing any wave. It will catch its prey, that is the fish, and that shape, which is not circular, which is a flat at the edge, and this shape has been used by bullet train, and this shape has made the electrical consumption also to be reduced by 15 to 20%. We can apply the biomimicry on 3 levels. One is the forum of the organisms, which is the inspiration for us to form the structure or form a building or form our own vehicles, etc. Secondly, we have to look at the process at which the chemical reaction takes place in nature and try to adopt it. The third level is ecosystem, what we have to see. All these 3 systems are shown here. One is the form, another is the look at the structure, and then we have to look at the system, what we have developed on all the 3 levels. Biomimicry is the approach by which we invent many structural shapes, and also we invent how to cool down the buildings naturally without wasting our energy. This video shows you how the structures have been imitated in our world. The Lotus Temple at Delhi. This is Burj Khalifa. So let me first talk about how we have used nature to develop some new materials. Two materials I will be looking at. One is the cement. The cement without producing carbon dioxide was first invented by Brent Constance from Stanford University. He has mimicry from the corals in sea. He has seen that it has produced a lot of reefs without producing carbon dioxide. How it is possible? We will just have a look at these slides. And the coral reefs are under the water structure that act as home for many marine organisms and are found to have a short distance from a coast. In Australia, I will show you a photograph taken from NASA, which shows that these reefs which produced has been developed under the coral reefs, and these are all not producing any carbon dioxide. This made the professor to think about producing cement without producing carbon dioxide. Coral reefs are composed of calcium carbonate, which is deposited through a combination of dead organisms and wave agitation. As I said, a coral reef underwater is an ecosystem characterized by reef-building corals. Reefs are formed of colonies of coral polyps held together by calcium carbonate. Most coral reefs are built from stony corals whose polyps cluster in groups. Coral belongs to the class of anthozoa in the animal kingdom. And binding material in the reef comes from the attached occupants, that is from the organisms. We get these cementitious material. So the professor from Stanford observed all this and he started developing from the seawater itself. He has developed the cement. How he did, we will see very shortly. So this is what the reef of coral, and you can see in NASA's picture, this is the coastal area, this is the border, and all these reefs have formed very near to the coastal area, and whatever you see, the white patches, all these are coral reefs, which we can see from our studies. The installation takes the waste of carbon dioxide from local power plant and dissolve it in carbon dioxide is produced from most of the factories. Take that and dissolve it in seawater to form a carbonate, which mixes with calcium in seawater and creates a solid. It shows how the coral forms their skeletons, and from this we have created the cement. This is the coral formation, and this is the processing which we take from the seawater, and carbon dioxide is converted into carbonate, and then the cement is manufactured. This is the coral which you see, and this is the cementitious material through the microscope which has been produced. There is a natural interaction between carbon dioxide, which is a gas, and water, and it comes to equilibrium, and the carbon dioxide dissolves in water, which is in the sea water, and this forms molecule of CO3, that is the carbonate, and the higher the concentration of carbon dioxide, more the carbonate is formed. The seawater has calcium, all of us know about it, and this forms the calcium carbonate. So while manufacturing the cement, we use, in our civil engineering, when I was studying, it was told that seawater is useless, we cannot use it for our construction purpose, but people have found its use in manufacturing the cement. They are dried out using the waste heat from the hot flue gas. And I will show you a schematic diagram of how the cement is manufactured. That produces a powder in a spray dryer, and which is becoming in the powder form as a cement. This cement can be used to make aggregate synthetic rock like synthetic limestone, or it can be kept dry as a cement and used in the concrete formulation. This is how the industrial carbon dioxide is taken into a unit, and clean air is left out, and it is absorbed into a salt chamber. Through electrochemistry, it will be converted into pure water, and then it will be taken to the dewatering and drying system, and cement is manufactured and taken into the dispensing unit. So our industry produces the carbon dioxide, but we use that and convert it into cement without producing much of the carbon dioxide during the construction. Then comes the second material from the nature. What we have seen is a self-cleaning paint. We paint on the surface of the building so that whenever there are dust resting on the paint, will be automatically cleaned by the water through the rain or any other form of water what we spray it. The spherical form of what happens on the lotus, if you observe a lotus leaves developed by biomimicry, what we have done, we can see that these dust will be cleanly taken out from the bubbles which are formed above the paint. This was observed by Professor Wilhelm Berthold, and he is with the lotus leaves. And if you see the lotus leaves closely, you can see that it never becomes wet. All the water particles which are coming in contact with the lotus leaf will become like a bubble like this, and it will dry out, or it will take out all the dust which are there on the leaf. And this is a close look under the microscope how this happens. This will become like a bubble, and the bubble will roll out of the leaf. Do you know what is the lotus effect is? This was the question asked, how the nature cleans the surface. This is what the professor was getting a question within himself, and it becomes very obvious that he studied the hydrophobic properties of the lotus leaf, and then he produced a paint which will be put onto the building, and a similar effect will be obtained. This is what happens in the close view of a lotus leaf. all the rainwater which comes in contact with the leaf will become a bubble. The lotus effect is nothing but formulation of the bubble. Bubble rolls out, it carries all the dust kept on or sticking onto the leaf, and it will roll out. This phenomena has aroused a great interest for its numerous potential applications in self-cleaning materials, and in many different fields this has been used. If you observe through the microscope, we try to get two layers of cleaning methods, which are the two structure. It is being, I will show you a photograph of the microscopic view of this leaf, which forms a waxy layer on the top, and this is due to hydrophobic effect. A double structure underpins water droplets that maintain their spherical shape was possible, and the waxy layer formed made the water not to stick onto the leaf. The lotus plant is always free of dust, and that has made us to develop a paint. If you look at very closely, I told you a picture which I show you. This is the double layered structure of the leaf, which is seen through the microscope, and this helps in formulating the bubble of water. This is what happens if the bubble is formed due to the structure which is there in the leaf. The eco-friendly paint inspired by self-cleaning lotus flower was invented. This phenomena has been named the lotus effect, and not surprisingly, it has inspired an entire industry of textile manufacturing of window glasses, sprays, and other products. Using the same physical technology that lotus flower used to keep dry and clean while growing out of murky water, the paint adds to the texture also. One of the most interesting eco-friendly paint developed by German company, the company name is ISPO or ISPO, and the paint what it has developed is similar to what the lotus effect has come. So you can see a look at these paints which is called as Lotusan. Lotusan is a paint which is manufactured available throughout the world, and this depicts how the bubbles are formed on the wall and it drops out. If there are any dust which are there, even it becomes like a waterproof, and also it tries to help to clean out the surface during the rainy season. The paint creates microstructures on facade, that is on the building, and similar to the microstructures on lotus leaves, in addition to keeping the building cleaner, the lotus sun can also reduce the building of or building up of algae or mold. As a result, maintenance cost of the building comes down. To give an impression of how effective the hydrophobic effect is, when you stick a spoon with the lotus leaf like surface into a jar of honey, it will never come out, it will just come out clean without any stain of the honey on the spoon. So you can see how the surface of lotus sun will help in formulating the bubbles, and the bubble which rolls out will make the surface clean. This is the paint which is available in market. I doubt about in India whether it is available. I have my own doubt. So this is the lotus plant with the leaf, and this is the paint. The video which comes now will all explain whatever I have explained to you. It takes another 3 minutes. Bear with me. It is a very good video which you should observe from the same professor.
Organisms make materials in and near their own body. So they can't afford to heat things up to astronomical temperatures or to use toxins or high pressures. So for instance, a spider, it takes what comes into its web. A fly flies into its web, it takes that, it does chemistry in water at room temperature, at very low pressures, and it creates this amazing fiber that ounce for ounce is 5 times stronger than steel. And this is being looked at now by fiber manufacturers. Nature's also really good at making hard materials like ceramics. If you take the inside of an abalone shell, which is that iridescent mother of pearl, that material is twice as tough as our high-tech ceramics. And what those mother of pearl layers are composed of is just very simple materials in seawater. So what happens is the soft-bodied critter releases a protein into the seawater, creates a template, and on this template there's charged landing sites. And the calcium and the carbonate in the seawater is also charged, and it lands in particular sites, which directs the crystallization, automatic self-assembly crystallization of this incredible material. And actually, it's a self-healing material. Beautiful architecture, incredibly benign manufacturing. And people are figuring out how to make ceramics without ever using a kiln. And this has been looked at for both reasons, for the blueprint and for the recipe of how you self-assemble out of seawater a hard material. The one thing that we have an awful lot of is carbon dioxide in the atmosphere. And we think of it as the poison of our era. Life sees carbon dioxide as a building block. Carbon dioxide is used by plants to make sugars and starches and cellulose. It's used by organisms in the sea to make their shells and to make coral reefs. And that chemistry, that CO2 to stuff chemistry, is now being mimicked. So Novomer is a company that takes carbon dioxide and turns it into biodegradable plastics. There's also a company called New Light, and their product's called Air Carbon, and they're taking methane, which is an even worse greenhouse gas, and they're using that to create packaging. Dell is using all their packaging now, made out of this Air Carbon, it's called. There are chairs made from it, the first carbon negative chairs in the world made of this kind of plastic that comes from CO2. The most used building material on the planet is concrete. The manufacture of concrete produces 5 to 8% of all CO2 emissions. But when you look at a coral reef, which is a concrete-like structure, you realize that CO2 is actually sequestered. So there's a company called Blue Planet that is now taking the recipe from the coral reef, and they're taking CO2 from flue stacks, and they're taking seawater, putting those together and precipitating out the raw materials for concrete. And in fact, they're now able to sequester a half a ton of CO2 for every ton of concrete. So if you can imagine someday us using carbon dioxide and sequestering it, long-term geological sequestration in the buildings that are all around us. That's what's exciting about biomimicry. You say to yourself, there's existence proof that there's another way to do this.
So that was about the material. One more video on how the paint was, lotus paint was created.
Of the
you can see
product.
this video.
Another kind of chemistry that we're always looking for alternatives to is a better soap, a better way of cleaning without phosphates and other things in our wastewater. And life also has to stay clean. Imagine a leaf has to stay clean in order to photosynthesize. So scientists a couple of decades ago put a lotus leaf, put that under a microscope, and found that the way it stays clean, it's not a chemical solution, it's actually a structural solution. It has tiny bumps, They're a certain distance apart, and they're waxy, and rainwater balls up on this surface. And dirt particles don't really adhere. They kind of teeter on the mountaintops. And the ball of rain, when the leaf tilts, picks up those dirt particles as it rolls off, pearls it away.
So
And it's
have a
become
look at
known
how
as the lotus effect.
dust is
Now there's
removed.
all kinds of products. There's fabrics with the lotus effect. Big Sky Technologies does that, and Scholler. And there's roofing tiles, Earless roofing tiles. There's a paint from a company called Stowe called Lotusin. And when it dries, it has that bumpy structure so that dirt really can't adhere, and rainwater cleans the building instead of sandblasting or applying chemicals and soap. So it's a whole new way of cleaning. It's another one of those paradigm flips that you often see in the natural world when you look to nature for solutions of the product.
So let's look at how we have imitated in the field of energy and water. This is a very interesting phenomena of using in Zimbabwe. A passive cooling system was used in a building in Zimbabwe, and this is called East Gate Complex. It is located in Harare. It's a commercial office building. It has used only actual requirement when it is compared only 5 to 10% of the air conditioning, and totally the building is been naturally cooled from the concept which will be explained now. This is the building in Harare which uses the nature's method of cooling the system. This system was evolved by an engineer called as Arup. It is an engineering company, and the architect who was working for this company is called Pierce, and he got the inspiration of this ventilation design from the termite mounds, and then he observed that there was a huge reduction in the temperature due to this concept of the termite mound. This is what it is compared, and this method of, there are a lot of ventilation which is happening inside this termite mounds, and I explain you how this happens. In Estate Center in Zimbabwe, very natural architecture has been created, and more number of office has been located in this building. And in fact, they say that after this building was built, the rent of each floor was increased after people observing that without spending on air conditioning, the whole building is under very good temperature control. So this is the comparison of the termite mound and to the building. In Zimbabwe, the gigantic mounds inside of which was observed by the architect, and how these insects were under very good controlled temperature was observed. And this system was carefully adjusted in the convection currents, and air is sucked in at the lower part of the mound. You can see this, how it happens. These are all the ventilators which are there in the mounds, and the air also will be sucked by the mounds at the bottom, and this hot air will be escaping through these ventilators. So these are all different structures which are being studied by the engineer and the architects, and they found that usage of this in the passive cooling in a building was possible. The outside air that is drawn in is either warmed or cooled by the building mass, depending on which is hotter. And the materials used in this building are all earthen materials like the brick and other materials, which was used to cool down the building, which was very hot otherwise in the nearby buildings which were built without air conditioning. This is a close look at the building. This center uses only 10% of the energy. Actually, it should have been used without this effect. The efficiency was directly responsible for saving about $3.5 million because of an air conditioning system that was adopted. This would have possible only because they studied the termite mounds in this fashion. The building looks like a factory or a cement silo, but it is the structure which has got at the center a chimney like where the hot air escapes and all the cool air comes from the bottom. This is what we even have practiced in many of the buildings by providing the ventilators below the lintels, and we have found that that has affected in cooling down the many buildings. This is a closer look of the building. Let's have a look at details of this building through this
In
video.
1991, architect Mick Pierce had a problem. An investment group in Harare, Zimbabwe, hired him to design the largest office and retail building in the country. But they didn't want to pay for the expensive air conditioning needed to cool such a large building. So that left Pierce with a seemingly impossible challenge. How do you design a building that cools itself? This is a termite mound. Millions of termites live inside these structures, some of which stretch an astonishing 30 feet high. Although these termite skyscrapers may look solid from the outside, they are actually covered in tiny holes that allow air to pass through freely. Like a giant lung, the structure inhales and exhales as temperatures rise and fall throughout the day. This termite ventilation inspired Pierce to use an approach known as BioMimicry, imitating the ingenuity found in nature to solve human problems. Meet the Eastgate Center. The building is made from concrete slabs and brick. Just like the soil inside a termite mound, these materials have a high thermal mass, which means they can absorb a lot of heat without really changing temperature. The exterior of the building is prickly, like a cactus. By increasing the amount of surface area, heat loss is improved at night, while heat gain is reduced during the day. Inside the building, low-power fans pull in cool night air from outside and disperse it throughout the 7 floors. The concrete blocks absorb the cold, insulating the building and chilling the circulating air. When the morning comes and temperatures rise, warm air is vented up through the ceiling and released by the chimneys. Thanks to this innovative design, temperatures inside stay at a comfortable 82 degrees during the day and 57 degrees at night. Not to mention, it uses up to 35% less energy than similar buildings in Zimbabwe. Since opening its doors in 1996, Mick Pierce's 90% natural climate control system has made the Eastgate Center a global landmark for sustainability. So, we must ask ourselves, if an architect could design a self-cooling building with termite-inspired climate control, what other innovations could Mother Nature inspire if we just paid closer attention?
Another application, what we have imitated is getting the water in desert area. This was invented by observing the beetles near Namibia, and where the beetles was getting the water. That particular desert was very near to the sea coast, and it could able to use the atmospheric whatever the water was available was condensed on this beetle, which I will show you through some sketches and videos. The country Namibia, which is the southwest Africa, along its coastal line had a desert called Namib Desert, which is, as all of us know, that in the desert it is very difficult to get the water, but the beetles were managing the water. People started studying this and how it was getting the water. You can see this beetle and its inclination. Whenever the air passes through this, it condenses the water on the back side of this because it is elevated, and the water will come through this channel. These are all channels created by nature. And this channel take the water directly to the mouth of the beetle. And this was used for agriculture system in this country. And the fog which was happening in the morning was used by these beetle for getting a sketch showing how the mechanism works. From the air, all the moisture is being collected on the back of the beetle, and then it is taken to its mouth. This is the beetle, and some of the explanation on the beetle, how it works. The wind blows on the backside of the beetle, and it has got some water moisture in the form of the moisture. The wind carries onto this beetle, and beetle gather the water and it makes it into a droplet, and then it drinks. So this was observed by the engineers, and they started manufacturing the water or collecting the water from air. How they did it, we will see through this sketches. Now they formed the outer shape of the building, or the greenhouse was formed in the form of a beetle, and whatever the air was blowing on this, the water was used to be collected in the tank, and it was taken down to some tank where it was converted into a clean water, and then it was used for the irrigation purpose. You can see how the water is absorbed by a porous cardboard also, and the wind blows over here, and the complete plant is under total control, and the complete area which is desert has been converted into rainwater harvesting through this beetle system which was used. Not only the agriculture people could able to benefit from this technique, but a wide range of buildings also could be designed to desalinate the seawater and provide a more sustainable source of fresh water. In the Canary Islands, a startup was doing this conversion of seawater to a potable water. So this, you can see the structure where the Las Palmas water theater has been constructed in the same way as the beetle was getting the water. And you can see the structure which is now inclined and has got the method of condensing the water, and it is taken through the channel. A close view of this beetle-shaped Las Palmas water theater, and a video on this will show you more on how the water is generated and energy is generated.
In the arena of conserving energy, there's a software company called Regen, and they've studied how ants and bees communicate to one another in order to find food sources. and to help streamline their foraging. And what they've done is they've applied these algorithms to sensors that they're able to put on appliances and drastically reduce peak demand by 25 to 30%, reducing energy bills by having these appliances communicate with one another and dial down the need for energy. At Caltech, students have come up with a new kind of wind farm that's based on how fish move in a school. So when fish are moving, they group together, and the ones in the front, with their sinuous movements, they kind of throw off vortices, these little spirals in the water. And then the ones behind them curve around those spirals, and actually they get flung upstream, saving a lot of energy. So what these students did was they said, why don't we take vertical axis wind turbines, and instead of spreading them out on the landscape, like you would with traditional wind turbines, why don't we pack them as closely as possible together? And they did this, and they found that when the first axes turned, they would create these spirals, and the ones behind them would start to turn even before the wind hit them. And they got 10 times more wind power out of a wind farm this way with a lot less land use. One of the things a thirsty planet will need is a way to find more fresh water. The Namibian beetle lives in the Namib Desert, drinks entirely from the fog that comes in a few times a week. It has these special structures on its wing scales that condense the water out of fog very, very efficiently, 10 times better than our fog-catching nets. This Namibian beetle effect has been mimicked by many companies trying to make new fog-catching nets for agriculture along fog coasts. There's also a small company that's called NBD Nano, and they're creating the fog-catching surface along the inside of a water bottle and creating a self-filling water bottle that will fill itself with the humidity in the air. Life is really good at filtering, especially to recover fresh water. If you think about a fish, every fish in the ocean is a desalination plant. It's living on fresh water in its cells, but it has to create that fresh water from salt water. So it's desalinating. So this idea of nature's membranes, we even have them in our bodies. We have them in our kidneys and in our red blood cells. And we have these little pores called aquaporins. And what they do is they actually, because of their shape and their charges, they are perfect for water molecules. Water molecules are attracted to the pores, to the channels, and then they move through them very, very easily, leaving everything else behind. And that's been mimicked in a membrane with a Danish company called Aquaporin. And they're doing desalination membranes that, instead of the energy-intensive reverse osmosis, which pushes water against a membrane, they're using the aquaporin membrane to pull water molecules through in something called forward osmosis, a fraction of the energy use and about 100 times more permeable than the normal membranes that we use in our big desalination plants. Agriculture is one of our biggest uses of water. And if we can find a way to grow plants with less water, that's going to go a long way for a thirsty planet. What scientists are doing is that they're looking at places where plants are growing in extreme conditions and asking, how are you doing that? A guy named Rusty Rodriguez went to the Yellowstone hot springs. And these hot pools have a grass growing around them called panic grass, which shouldn't technically be able to live in those conditions. But he dug down in the roots and he found that there was a fungal helper wrapped around the root that was allowing the plant to grow in these very hot conditions. And he was able to inoculate seeds with a fungus that enabled the plant to grow 5 times more rice with half the water use, which is really, really important if we're talking about a climate-changed world. where drought is the new normal.
So that was about the energy and water. Finally, I will look at how we have evolved in the building. In the building, we have created what is called as self-healing concrete, which was observed from the nature only. The cement production is the primary component of concrete, contributes more than 5% to the human generated greenhouse gas emission, which gives a lot of carbon dioxide to the environment. So Henk Jonkersine is a Dutch microbiologist who has invented the method of self-healing in the concrete. You can see a concrete with a lot of porous, then it was subjected to compression and then found that this can be used as a self-healing. You can see there is a crack in the microscopic view, and that gets healed up by itself by producing a chemical which is which we can say is smart cement or a concrete, which can help in developing the self-healing buildings. This is what happens. The cracks are all formed in the concrete, and that gets accumulated with a cementitious particle which are developed by a smart material which is used in the cement. This is a close look at the different natural cementitious material like corals, and from corals it has been invented to develop the self-healing concrete. You can see here, this is how the crack has formed, and it gets filled up within a week. It gets cured by itself. This is an invention we have found from the nature. And I just skipped the video. Already we have seen sufficient video. These are all some of the references I have made, and you can also go to these websites and find more interesting. My aim was here to collect more information than doing any research. So in future, I may get interested in doing the research. I hope that from Johnny Dennis, the more our world functions like the natural world, the more likely we are to endure on this home that is ours, but not ours alone. We have creations. So we should not only think that we should not copy. There was very recently on WhatsApp, I had a message telling that cuckoo speaks its own language, so it is free. But when the parrot copy other language, it has been put in the cage. So don't copy, but imitate. Imitate is different than copying. So thank you very much for your patience hearing. You can contact me on these contact numbers and also on my email or to Sharath.
Oh, thank you, Dr. Suresh, for this wonderful presentation. It was very informative. It covered diverse topics, but all of it was very relevant. It must have taken a lot of effort from your side to prepare this presentation. Thank you, Dr. Suresh, for putting in so much effort and generously sharing your knowledge. Before I pass on the baton to Lalit Saptashri to take questions from the participants, I take this privilege to pose the first question. Okay? I have a philosophical question to Dr. Suresh. Question is like, humans identify, we can only identify biomimicry only if we could perceive it, right? Otherwise, we won't be able to identify them. So our observations are limited within the observable universe. And then there is a whole unimaginable, unfathomable, unobservable universe. So the question is, do humans deserve to claim novelty in anything we create? So the other way to pose the same question is, are humans capable of creating anything which already does not exist? So what are your views?
Now, only through our observation we imitate. 99% of what we have invented is from the nature only. So what I say is, we are intelligent, no doubt. At the same time, if you see a kid imitates another kid, which all the technology or the techniques to operate a small, maybe a mobile, through imitation of another kid or by its parents. So always we have tendency to imitate others. So though we are intelligent, by observing the nature, we have to develop our own technology to solve human problems.
Thank you. Now, Dr. Lalit Saptashri can take over the question and answer session. Lalit?
Hey, thank you, Dr. Suresh. It was really interesting and informative session, and I'm sure like everybody from the different background will definitely find some other ways to get inspired from nature and try to solve problem in their domain.
I have only little knowledge. I hope I could able to answer your question. Okay, tell me.
No, sure. I will open the floor for people to go ahead and ask. They can unmute themselves and ask question, or they can type here and maybe I can moderate here. Go ahead, people. If you have any questions, you can type it or unmute yourself.
Unmute and ask the question.
DSR Gupta says he wants to see the reference slide again.
Okay, sure.
So is Vikas Shetty asks if the recording is available for everyone later on. Will it be made available?
Yes, yes, it will be made available. We are recording the event, so it will take us some time, or like, maybe 2 weeks or so. So then we'll be sending it across to the participants. Thank you.
This is the reference asked by one of our participant. Can have a look at it. If you can send me an email to my mail address, I will be able to share also my PPT to you. You can get it. This is my email address. Please note down and you can write to me. I will definitely able to help you in getting more. I have got a lot of more references also, and I can share it to know more about this subject. I hope I am able to initiate some interest with the people who are attending this webinar.
Dr. Suresh, it will be difficult if multiple people contact you. So what Smita can do is she can just send the information to all the participants.
I can send a PDF to Smita and you can always
collect. Yeah, she can share. She has the database, so she can send it to everyone.
Sure.
Okay, there is one question from Vikas. So, has there been a natural attempt to create a natural alternative to the plastic and packing?
Yes, as far as I know, very little work has been done because nature has not shown us how to pack our items, particularly food, and send it to others. I hope the inventors are looking at it to replace the plastic. As far as my study through these whatever available resources, I don't find any alternative to plastic so far.
Sir, Parsharthi here from Bangalore. I'm 1987 batch from IIT Mumbai. Question for you, sir, that you have, thanks at the outset for a very good informative session. So what kind of a research is happening in Indian academic institutes in this field, sir? So you have done your PhD, you have done in across all the institutes in India. If you can kind of tell us a bit more on what kind of a work is going on in Indian academia and industry.
Yeah, to tell you very frankly, very few institutes are doing the research on this. Still, only I can be able to find from all the literature that Only American and German companies or universities are doing more work. In India, the work happening is almost nil. I don't find, I'm not aware really. From the whatever the literature available, no Indian universities have trained about biomimicry research.
So, Dr. Bapu Gowda Biradar asks, are there any codes available for designing biomimic structures?
No, ACI has referred to this biomimicry in one of its article, but no code has been formed so far. It is at a very initial stage. A lot of work need to be done in this area. So those who are interested to pursue their PhD and research, this is a good area to start with.
Okay, Suguna has one question about sir, interested in working on the self-healing concrete. Any references available for producing the required bacteria for the same?
Yes, lot of work is available abroad and also in India. People have found, if you refer to IIT Chennai or IIT Madras journals, it is available. I will try, if you contact me, I will try to give you some reference on self-healing concrete. A lot of work has been done on self-healing concrete in India.
Okay, thank you, sir. I guess this is extension to okay, Sharad is okay. Sharad only has asked this question. I guess, are humans capable of creating anything which already does not exist?
See, human beings are also like other organisms. So we may have, somebody may have an intelligence to create his own to solve his problem. We have created many medicines on our own without looking into the nature also. So definitely, but not many references are available on what human beings have created, but most of the creations are from the imitations.
Sirisha has raised her hand. I think she has a question.
Yes, sir. It was a very nice presentation, sir. Thank you so much. And I would like to ask, it's a very, maybe a general question, how to make it a big revolution such that it reaches the rural parts of India, first thing. And we do have many tribal areas and tribal people who construct very biomimic houses, I can say, probably using a simple mud and thatching, etc. So we as engineers probably have a lot of responsibility to conserve energy and water using this biomimic technology. So what are the various things such that it reaches the rural parts of India, sir? That's my question. How can we do it?
In this area, a lot of work has been done from Indian Institute of Science and the building material institutes. And if you contact Professor Jagdish of Indian Institute of Science, you will get a lot of information. Professor Reddy is there, Professor Nanjun Rao. All these people are working, and we have also worked in this area on green building and alternative building technology, where we have used bamboo mats for supporting the mud wall. If you refer to any of the books by Jagdish, who has written on building material, alternative building materials, you will be able to get a lot of reference on this. So in that area already we have, in India, we have worked on the alternative building technology applicable to rural areas.
Thank you so much, sir.
Okay.
Any more questions?
Okay, I don't think there are any more on the chat. So maybe we'll keep you if we get any more questions, Dr. Suresh, over email.
Please. I'm very happy to answer all the questions if possible.
That's amazing. A lot of questions have come up actually. So can you please
One more question.
the screen?
Mayank has a question, I guess.
Audible, sir?
So can you please
Yeah,
stop
you're
sharing the
audible.
screen?
So my question is that is in biomimicking is we are finding a sustainable solution for our general problems in engineering field. As in India, we are witnessing right now the electrical vehicles are being pushed and booming more in the market.
Yeah.
But as being pushed, but they are coexisting with the fuel-driven vehicles. Will be costing more in a short-run period.
See, they are only looking at the substituting with the petroleum, but at the same time, they should also look into how to generate more electricity and what are all the general available natural sources for developing the electricity through either solar method or from the wind mills. So these things should come up more before we totally convert into electric motor. I feel that the sector of electrical generation should be taken up seriously, and we should find an alternative than the petroleum.
Yes, sir. And leading related to this second question is that it as the human tendency is if it is becoming cheaper. Like for example, if we the cost of traveling in EVs are for 1 rupees, we can travel 1.4 kilometers roughly. This will give tendency to people to travel more and means the psychologically way which it's like that. We are using more and more energies if we are getting at a cheaper rates. So it will hamper other coexisting technology too.
Yes. No, that is a very social problem what you are asking. People did not stop at all, even though the petrol cost has crossed 100 rupees. You can see a lot of all the tourist places are getting crowded. But at the same time, as I said, we should focus our generation of electricity through natural solar or wind energy, and we cannot stop people. Even though the petrol goes to 200 rupees, people will more rush towards the tourist places. I don't think only not inventing the electrical vehicles or with the invention of the electrical vehicles, more tourists will move around. I don't think so. But we have to look at generating electricity through solar system and wind energy.
Thank you, sir.
I think we can wind up, Sharath.
Yes, I think there is one more question. If you can answer.
Yeah, sure.
I think Dr. Basan Gowda has a question.
Yes, sir. Good evening, sir.
Yeah, good evening.
Sir, we are working. Yes, sir. We are working on biomimicry in civil engineering field. We have carried out some literature studies, but we have doubts in assuming the section properties. For example, if I want to imitate a tree structure in a column of a building, and when I try to analyze the building, subjecting it to loads, on what basis we have to assume the dimensions of either stem and branches, sub-branches of a tree? Are there any guidelines to assume the sections? And are there any guidelines to assign lateral loads? Like if I use method as one of the methods,
Your first
and
question is on the
assign the lateral loads, like nodes where.
Yeah, shall I answer? Your first question is on the material property of the timber or the tree, whatever you're asking. Code is available, Indian code is available on the timber structures. But as far as the stability of the structure is concerned, we have made a lot of research and a lot of papers are available. We have imitated the tree to even make a cantilever up to about 10 to 15 meters. So lot of research work has been done. There is no need to do more research, but we have to use them and then design the requirement of the code.
Okay, sir. Thank you. Thank you.
So I do not actually have a question, but I have one comment to make from the first-hand experience. Sometimes, mimicking the nature becomes inevitable. For example, the field I'm working on, let's say, in the field of autonomous vehicles, where they're trying to develop the driving behavior models. Even though the machines are capable of much superior performances, because they do not they have superior reaction times, they do not get distracted by uh, uh, other activities. Even though they are capable of much better things, machines are being developed, models are being developed to mimic human driving behavior. So sometimes mimicking human driving behavior or mimicking nature is inevitable. So that was just my comment.
Yeah, definitely. We have to live on biomimicry only. We mimic either the nature or a human being manufactured the machines. So in other way, I can say that the machines, what robot and other things you have developed is all mimic of the human being only.
I guess there are no more questions. We can wrap up. Dr. Smita?
Yes, thank you. Dr. Suresh, can you please stop the screen sharing, please? So we come to the last part of the talk. I'd like to give a vote of thanks to everyone who has contributed actually to this event. Right. So, hi, this is Meeta, joining from Bengaluru, India. Thank you to all our participants, for joining on a Sunday evening. Thank you so much, Dr. Suresh, because we realize you have actually given a very, very informative talk. It's a very, very interesting topic, and it's been amazing to see the, the interest among the participants. And also, it's very interesting to know that there is very little research which has been done in India. So which means it's a very fertile field to actually for researchers, for PhD scholars to actually move into. We are very, very thankful to you for all the effort that you've put into put this very interesting presentation along with a lot of good videos together. Thank you so much. We'd like to thank the board, IIT Alumni Association, and our president, Dr. Deepak Patil, who joined us earlier in the event, for enabling the Mysuru Alum Network to organize its first open virtual event, and which means we were allowed, to open this event to alumni across chapters. So we are yet to become an official chapter, but we do hope sometime in future, Lord willing, we'll actually become an official chapter of IIT Bombay Alumni Association. So we're very thankful to the board. We're also thankful to Praveen Malla, Dr. Praveen Malla, who is our board member and who helped us in publicizing the event in some IITB alum groups on Telegram. We are also thankful to Dr. Suresh. He reached out and he asked, so we have opened this event to non-IITB people, and we're very happy that a lot of people from NITs, from NIE Mysuru have actually joined. Thank you so much, to everyone for attending. We'd like to take a minute to thank all our the people behind the scenes. So we'd like to thank Devesh Khatu, who's the CEO of IITB AA, and his entire team, Sharba Sen, who would be helping us to put the event together in the monthly alumni newsletter. And also we'd like to thank all the alum volunteers. I'd like to especially thank all the alum volunteers who actually worked, hard to put this event together. I remember I reached out to Dr. Suresh on 20th of October, and he came up with this topic, which is very, very, very interesting. So I think Shrikant Banot, my teammate, joined a little while ago. So he is in Lucknow. So it's interesting. We formed an inter-new alum network core team, to organize this event. And Shrikant has joined the core team from Lucknow. So he's part of the core team for Lucknow, but he joined the event core team for this event. he designed a very cool poster. He also helped us with the, creating the Google form for this event. We'd like to thank Sharat, who I reached out earlier today, which means IST Indian Standard Time, which was Canada night for him, and he joined early morning, to do anchor giri for that's how we talk in IIT Bombay, anchor giri and moderator giri. So he's doing anchor giri for us, early morning from Canada, because he told me, Smita, Dr. Suresh was my teacher in IIT Mysuru, so it will be a pleasure for me to do so. I'm also thankful to Mr. Lalit Saptarishi, who is a design engineer at Intel Bangalore, and who also agreed earlier today, to moderate this event. And I realized it was a very good job that Sharat and Lalit did together to act as moderators. We'd like to thank all the alumni friends in Bengaluru chapter of IIT Bombay Alumni Association, who helped us in publicizing the event on Bangalore chapter groups, and our alumni friends in other chapters like Australia, Gujarat, NCR, who also helped us, in publicizing in their chapter groups. So that so the interesting part is this is an event which has received 111 registrations, and usually we found 1/3, like 30 to 60% participants may usually join. So it's good to see, at the peak, we had 33 to 35 participants who had joined actually live for the event. A recording will be available, and we'll be sharing that at some point of time, like maybe sometime in November, because we work as alum volunteers. So, and for that, we are thankful to Divyam Goyal, my teammate again, who's an executive committee member in BLR chapter. And so he is the founder and CEO of AttainU. So we're very thankful to AttainU for enabling us to utilize the Zoom Pro platform so that we could actually do the event seamlessly on Zoom, and also do a recording which can later be shared with the participants. So thank you so much, Divyam, and thank you so much, AttainU. We look forward to organizing more events, and we look forward to joining you. We look forward that you would be joining with us, sometime again in future in 2022. So please stay tuned. Thank you so much.
Dr. Suresh, it was very nice meeting you after so many years.
Yeah. Even for me, I was wondering who is Sharat is. Then I recalled. Then I got, after seeing your face, I could able to completely picturize what we were meeting in the college. Thank you very much, Sharat, for
thank you, sir.
doing this work. Thank you very much.
Thank you, Smita, for this opportunity.
Thank you, my pleasure. And thank you so much, Dr. Suresh, for your...
Yeah, Smita, I will be sending you PDF file along with some videos. I will put it in a folder and send you. You can share it to whoever is required. Okay?
Right. So maybe on need basis, whoever asks, we will share it with them. Okay.
Yeah. Thank you. Thank you very much.
Thank you.
I'll
Thank
be
you so
visiting
much.
India in February, sir. I'll just try to meet all the professors. I'll be visiting India in February. I'll try to meet all the teachers.
Yeah. Please come and meet us. I'm not in NI now. You can come to my house and meet me. Okay. Thank you very much.
Okay. Sure, sir. Thank you.